Saxon Algebra 1, lesson 109. You guys, we're making great progress. Let's look at where we are. Today is May 19th, so this is the homework that's due today. Those are the lessons I gave you last week. So today we start in on 1, 2, 3, the last 3 lessons of class. This is going to be over in no time. The last 3 weeks of new lessons. I said it wrong. This is going to be over in no time. We're getting on the home stretch. These lessons are a little bit different in some ways than the lessons that we've had before. I'll say more about that as we approach each lesson. Some are super relevant. Others, John is kind of planting seeds for what's going to happen next year in Algebra 2. So sometimes these lessons feel a little off the wall, but I'll deal with that as we go. But I just wanted you to see we're getting there. And then when we get to the week with the final, we'll do that like I did the midterm, where I will drop it off at your house, you'll work it, and you'll put it back out on your porch, and I'll pick it up, bring it home, grade it, tell you how you did, and guess what? It'll be summer, and we won't have to deal with math anymore. Yay! Okay, let's talk about 109. 109 is a gem. 109 is a really good lesson that I think will fit into your heads well. It's very relevant and useful. It's called Advanced Trinomial Factoring. Oh, that sounds so impressive, doesn't it? You know quite a bit about factoring already, and that is where we take something like this, right? And we say that's a trinomial. It's got a squared term, a plain x term, and a plain number. And we want to factor it into a pair of binomials. Sometimes we say equals 0, and we actually solve it. Other times we say, no, don't worry about making it into an equation. Just factor the expression. And so what we do is we know, oh, yeah, it's going to be like this, and it's going to be like this. And we need to find 2 numbers that multiply to this and add to this. Okay. So we see right away that 3 and 2 will get us there. They multiply to 6. Now we have to just figure out how to set up the minus sign so we'll get the right answer. We want it to be minus 3 and plus 2. That gives us the minus 6, and it also gives us the minus 1 that is implicitly right there. Okay, so that's how we do it. You guys have been doing that for a long time. By now, I'm sure you're really good at it. What I want to do is I want to extrapolate a rule from this that we can talk about in a more abstracted way. If we remember that this is the standard form of a trinomial, ax squared plus bx plus c. I wrote it above this so you could see. Let me write it again because that's confusing. Ax squared plus bx plus c. And then what we had was x squared minus x minus 6. Okay. What we have seen is that our rule is we need 2 numbers that multiply to c and add to b. Right? That's been our rule up till now. We haven't always stated it in these terms. We've talked about the last number and the middle number, but now we're just giving names to those, right? And part of the assumptions we make when we do this is that the a term is always equal to 1, right? Because we're used to seeing things that just start with an x, right? And that makes it super easy for us to know that that's how we fill in the beginning. We haven't dealt with expressions like this where there's a different value for the a term, okay? So this is the rule if a equals 1, right? Which we don't even bother writing it down. But this is the set of rules we use to factor a trinomial if the a term is equal to 1. But what if a is not equal to 1? Oh, that's what we're going to deal with today. That's the advanced bit. Okay, so let's look at the first example. 109.1. John, first of all, messes with us. He tells us to factor. Okay. Well, that's really cute, John. I see what you did there. You messed this all up so that we would have to rearrange it. So let's fix it first. I'm just going to change the order. Notice there's no equal sign, so we're not swimming any fish. We're just rearranging our terms. So we're going to have 2x squared, then this one, minus 7x minus 15. Okay, now we're in the proper order, right? So now I'm going to write again our standard form of a trinomial. I'm going to write that underneath it. ax squared plus bx plus c. So now we can see what's our a, what's our b, and what's our c. Notice that the signs are part of the package, and if there's a minus, I have to be careful to include that. Now, here's our new scenario. If a is not 1, we're going to do it just a tiny bit differently. What we're going to do is we're going to multiply a times c, and that's the new number that our two numbers have to multiply to. Okay? So our two factors that we figure out is a times c, and then they still have to add to b. That part's exactly the same. Okay, so the first step in advanced trinomial factoring is to find out what a times c is. And we just multiply 2 times minus 15. So it equals minus 30. Okay, so now we're looking for two numbers that will multiply to minus 30 and add to minus 7, right? Okay, and what might those be? Just a second, I want to rewrite my original thing because we're going to work from there. All right, so we think about that and we go, oh, 3 and 10, right? If we had minus 10 and plus 3, that would give us the minus 7. So here's what we do. Instead of going right to this presentation, we then have to write as 4 terms. This is a little weird. We've never really done anything like this before. But what we're saying is that the two numbers that we find are minus 10 and positive 3, right? They multiply to this, they add to that. So here's what we're going to do. We're going to rewrite this trinomial, but instead of having 3 pieces, we're going to make it into 4 because we're going to write this middle term as minus 10 and plus 3, all with x's. I'm not saying that, but they're there. So minus 7x becomes minus 10x and plus 3x. These are equivalent, right? Minus 7x plus 3x are equal to minus 7x. But there's a reason we want to write it this way. And P.S., John does not teach this lesson the way I do in the book. So his is a completely different thing that involves lots of guessing. My way's way better. Okay, so this middle term gets split into 2 terms using the special numbers we found according to these rules. The first bit and the last bit stays exactly the same. Okay, so all we did was take this middle part and split it according to the 2 numbers we found here. Because they have to add to b, we know that these 2 are going to equal that. But this is a good thing to check as we're going along to make sure we didn't screw it up. Okay, now we're going to factor by grouping, which we just learned how to do. Just a few lessons ago, I don't want to flip through my book and get distracted in finding out that lesson number. But we're going to factor by grouping. So what does that look like? The first 2 and the second 2. We're going to factor them. Now, before I go on, I want to ask myself a question, because you're not here to ask it for me, and you guys probably would. How do you know which one of these to write first or second? Should we have written minus 10x plus 3x, or should we have written it the other way, plus 3x minus 10x? Spoilers, it doesn't matter. Either way, it will work out correctly, and you don't have to worry about it. So as long as you get the right numbers and signs, it doesn't matter what order these are in. So now we're going to factor by grouping. We're just looking at these two. We're saying, okay, what do we have in common between these two? And we see, well, 2, because 2 goes into 10. And there's an x. We can pull out an x. So 2x is what we pull out. And what do we have left? X minus 5. Right? 2 from minus 10 gives us minus 5. And then over here, what do we have left? We can pull out a 3, right? A positive 3. So we write it as plus 3. And then what do we have left? X, and then 3 out of minus 15 would be minus 5. Look what happened. This will always happen in these problems. Always. They're magical. They're beautiful. They're so fun to do. So our final step is to turn that into a binomial. And then we only have to rewrite the second binomial once. That, my friends, is our final answer. Oh, I'm doing that thing where I'm checking the solution in the book. There it is. But I looked at the wrong example, so I'm like, how could I be so far off? Well, it's the wrong problem. That's correct. Yay. Okay, we're gonna do it 2 more times just to make sure you've got the groove down, but kind of fun, right? The big thing to remember is that we're gonna multiply a times c to get our multiplying number. And then we have to do this factoring by grouping thing at the end where we split and then we factor. So that's a little different, but it's not hard, is it? I don't think it's hard. We've done things way harder. This is a little mind trippy, but it's not hard. Okay, example 109.2, factor. Well, John is a buddy and a pal this time because he at least puts the trinomial in order for us. And I'm just gonna write this up here so we remember what the hex we're doing. That's what the heck and me writing x at the same time. Okay, so we remember that our first step is to find those 2 numbers that multiply to a times c and add to b. So I'm rewriting down our little rule here. Okay, a times c in this example is minus 6. Okay, so they have to multiply to minus 6 and add to minus 1. Okay, so 3 and 2. We'll want it to be the negative with the 3 and the positive with the 2, right? So we get the negative 1 in the end. So our numbers are 3 minus 3 and 2. Sorry, I was getting all crazy. And this is confusing because look, they're the opposite of these numbers, right? It's not 2 and 3, it's 3 and 2. I mean, minuses. You see what I'm saying? That's what my brain was sort of pinging here. But minus 3 times 2 equals minus 6. And minus 3 plus 2 equals minus 1, and that's a minus 1. Okay, so we're going to write these 2 numbers in place of this. So it's going to be, I'm going to write it plus 2x minus 3x. Notice we put the x's there because we're trying to replicate that term just with using 2 terms that equal that. So we have to make sure we tuck those x's on at the end. Okay, so that's good. It multiplies to minus 6. That's what we want, blah, blah, blah. These come along for the ride. These don't change at all. 3x squared plus, oh, I already have the plus there. I don't need it. And then this is just minus 2. Okay, and now we'll factor again by grouping. What can we pull from this? Just an x, right? And we get 3x plus 2. And here, now this one's a little tricky. We know ahead of time now, because this is not our first advanced trinomial factoring rodeo. We know that this and whatever we create here has to be the same. We want it to be 3x plus 2. So that helps us see, oh, we need to pull a minus 1 out of there. That will flip the signs because otherwise it's perfect, right? So sometimes if you get one of them, it helps you factor the second one. because you know what needs to be in here. If you ever try one of these problems and these two chunks don't match, that means you did something wrong. They'll always match if you did it right. Okay, so when we pull out the -1 here, we get positive 3x plus 2. Now they match. I'm happy now. I don't even need the answer. Okay, and then our last step is to write it as a pair of binomials. We gather up these pieces, x minus 1, 3x plus 2. Okay, cool, right? That's the right answer. Yay, I'm gonna smiley that again. Now, I wanna show you something. I told you before, but I want you to see me do it so that you believe me. I'm gonna go back to this stage and I'm gonna write these down in the opposite order just so you can see how it works out. So it would be 3x squared minus 3x plus 2x minus 2. See what I did? I took these two terms that add up to the x and I just reversed their order. It's the same number and sign, minus 3 plus 2. They've got the x's after them because they have to equal minus x, which they do. But I'm just reversing their order, and now we're going to solve it again, and you'll see whether or not I get the right answer. I told you that I would, but you know, sometimes talk is cheap, let's say that. Okay, so I'm going to factor this. What can I pull out? Well, now I can pull out a 3x, and that leaves me with an x and a minus 1. Remember that when you factor everything out, it's 1, so then if you distribute it, you'll get that 3x back again. And then here, oh look, we can pull a 2 out, and what do we get? X minus 1. Now, let's compare this to this. See, what happened is before, the two pieces that were on the outside of the parentheses are now the pieces that are on the inside of the parentheses. And the part 3x plus 2 that's on the outside this time, last time that's what was on the inside. That's how this changes based on the order that you put in these two new pieces. The way that you put those in determines which binomial will be the one they have in common and which one will be the extra pieces. So it's the same answer. 3x plus 2 times the quantity x minus 1. This is the right answer. Notice it looks exactly like this answer. It's just in a different order. Remember that order in multiplication doesn't matter, so it's okay if those parentheses are in either order. Remember that what does matter is the numbers and the signs within match. So we're good. Okay, one more. (5x squared minus 13x minus 6. I'll just tell you right now, I really like advanced trinomial factoring. It tests you on some really interesting processes, and if I were writing the final right now, you can bet $5. You could bet even more than that. You could bet $16.50 that I would have one of these problems on the test. I really like them. Okay, so here we are again. 5 times minus 6 equals minus 30. So I jot my little note here. A times C equals minus 30. And then I know I'm looking for two numbers that multiply to this and add to this. And I first think of 3 and 10, but that would only work if this was positive, right? There's no way with 3 and 10, one of those would have to be negative in order to get the negative 30. And now I'm looking at either 7 or minus 7. So this, nova. But I get excited because 3 and 10 seems like it should work. But you know what? Math isn't always what you think it is. So now I'm going to try again. And I think of the other, there's 5 and 6, but that doesn't get me there. That's got a difference of 1. What about 15 and 2? Negative 15 and positive 2. That multiplies to that, and it adds to minus 13. Bingo. Okay. If you can do this part of the calculation, you know, this figuring out part, if you can do it in your head and get it right all the time, that's absolutely fine. But especially in the beginning, most students benefit from the clarity of thought that happens when you write down your ideas. So I highly recommend you make little notes to yourself as you're figuring out those numbers, especially in the beginning, because now we're having to multiply and hold this product in our head while we test the different combinations. So give yourself a break and just make notes to yourself. All right, so I want to switch this so that it's written with these two terms. I'm just going to write them in the order that I thought of them. As we proved up here, this order doesn't matter. It'll just give me my answer in a different order, but it doesn't matter. So I've split that out. Let me double check again. This multiplies to minus 30, check, and it adds to minus 13, check. All right, so now I can copy these parts. 5x squared minus 5x plus 2x minus 6. I'm going to factor by grouping. I'm going to trust that it'll work out. Here, I can pull out a 5x, and I get x minus 3. And then here, I can see if I pull out a positive 2, that will give me the same thing. I'll have x minus 3. Those match. That gives me great assurance that I've done it correctly. And for my final answer, basically what we're doing here is we're, what's the easiest way to say that? This form and the way we're gonna write it here is just a different way of showing the multiplication. This is kind of like distributed, and we're gonna undistribute it. Right? This and this are exactly the same thing. We're just pulling, instead of multiplying each part of this binomial separately, we're just going to write it as one binomial times another binomial. So mathematically, these two statements are equivalent. This is just like a cleaner version, and that's our final answer. 5x plus 2 quantity times quantity x minus 3. Yay, we did it. That is lesson 109, you guys. I love it a lot, and I hope that it warms your heart even the tiniest little bit. Thank you. Goodbye.